So what's the deal with 3D printers? It has the potential to revolutionize lives and industries in ways never previously imagined. Designs are now only limited by your creativity, and in the not too distant future, you may find yourself downloading and printing off a new bike or the latest pair of shoes. Now, the idea of printing your own food or a new heart for transplant may seem abstract, but scientists are making strides into turning this into reality. 3D printers used within the oil and gas industry are also being investigated. Natural gas, for example, has many uses including power generation, providing up to a quarter of the world's energy consumption, and heating and cooking in homes. However, transporting the gas is an issue as it takes up a large volume of space. So to transfer it over large distances, it is often cooled into liquid or LNG. This shrinks the size of the gas dramatically and can then be shipped overseas for use in other countries. But to do this, it first must be refined to remove impurities. The first process involves the removal of carbon dioxide, which otherwise tends to freeze when cooling the gas to a liquid. This can otherwise cause significant problems in the plant. To remove the CO2, a liquid is passed over the gas via something known as structured packing. The structured packing aims to increase the area of contact between the liquid and the gas and improve the rate at which CO2 is transferred. However, the current design is quite simple and is somewhat reminiscent of a corrugated suburban roof. So the question is, how can we use a 3D printer to do this process more efficiently? 3D printers allow us to create intricate designs to increase the surface area of the packing and could be inspired by elements of nature. So after coming up with numerous ideas, they were then modelled and printed. Computer simulations were also run which produced colourful visualizations. The prints were then tested on a small-scale experimental setup. And these were the results. The ideal situation consists of a checkerboard pattern. The existing design, as you can see, has large regions of blue and white, which is less than ideal. Our design produced an image that is much closer to the ideal case, as you can see on the left. As such, this design shows good potential and with considered development will hopefully play a part in the plant of the future.